Tornado charts and scenario analysis are considered static analytics. So assuming again that we're back in the PEAT discounted cash flow module, whereupon we had all these different projects with data entered. And if you recall, we had some portfolio analysis of our key performance indicators like NPV, IRR, and so forth. Now, assuming that's already done, we can go to Applied Analytics tab. And in Applied Analytics, you have Static Tornado and Scenario Analysis. So let's go through the Static Tornado real quick. Down here it says select the option and output variable to run. So we can choose from any of these 10 projects the key performance indicators. So NPV for project 1, MIRR, ROI, and so forth, all the way down to project 10. By default, the sensitivity is plus or minus 10%. So you're perturbing each of your precedents, each of your input variables plus or minus 10%. Clearly, you can change this. Default also shows the top 10 variables. Here I've just changed it to 16 variables, and you can see as many decimal precisions as you wish. So if you have a large data set, a large number, chances are you would reduce the number of decimals and vice versa. Then you can decide on the granularity of the sensitivity analysis. You can do variable groups, line items, or individual unique inputs. So individual unique inputs is each input value is assumed to be unique. So for example, revenue for year 2018, revenue for year 2019, for global sales, all right? So each of these are unique. Line item just means we will collapse everything as something called revenue, or we collapse everything called right here, sales revenue, global sales. So the entire line, we will call it global revenue. So for instance, if we go back to project 1, if we do unique inputs, each of these will be considered unique inputs, and we're perturbing each of them individually. If you use a line item, this whole entire line item would be considered as a single variable, and we will change it plus or minus some percentage. Now compare that to, let's say, direct costs, where we have multiple rows in this case. And by the way, if you recall, we can add in as many rows as you want to. So these are direct costs, and there are 4 of these line items, or sub-direct costs, sub-line items. So what we can do also is group those as a single variable. So we can say direct cost is actually a single variable. So regardless of how many line items there are and how many years and so forth. So it depends on how much level of granularity that we're looking at. So in this case, we'll just simplify and use variable groups, and we say revenues is one group, discount rate, tax rate, and so forth. So you see a tornado analysis, and this video assumes that you are somewhat familiar with tornado analytics. It just means you're perturbing each of those input parameters one at a time, again, one variable at a time, and seeing what the results are. In this case, we're looking at net present value as the key performance indicator, the KPI. So for example, we're looking at project 1. If you look at project 1's value economic results, the NPV is 608,388. So if we come back here, we see that the base value for NPV is 608,388. And these are your inputs. And again, by default, you can show 10 variables, as many variables as you wish. Just remember to click compute, and your table will be updated, chart will be updated accordingly. So in here, we can see what happens to revenues, and revenues has the highest impact. It's the highest, bang for the buck in this case, if you will. So what happens is you look at input changes and output. So we're looking at base case 6021. That's the total sum of my revenues. If I up this by 10%, this is my input for revenue, 6623 and so forth. And if I reduce it by 10%, this is what you get. If I increase revenue by 10%, my output goes up to 745,000 from 608. If I reduce my revenue by 10%, this is what happens to my NPV. It goes down. So the absolute swing in this case, the effective range is $273,000. That's the impact potentially, given a plus minus input change of revenues of 10% in this example. So we rank it from the highest effective range to the lowest effective range, as you see here. So by changing net working capital, it really doesn't have any impact at all, for example. So if you have a tornado that looks like this, don't worry about things that are way down here, because it has very low impact to your analysis. Spend more time analyzing variables and inputs that's up here that has highest impact to my, if I move one of these inputs a little bit, the dial is going to move significantly in terms of net present value. So you can keep doing the analysis for any one of these KPIs for any of these projects that we've run. So very easy to do. Again, you can rotate the chart, change colors, you can do whatever you wish. Green means go, red means stop, clearly. So green on the right-hand side. The x-axis in this case is my net present value. So NPV base case was 608, so you see it crosses at approximately $608,000. So whatever you choose as KPI from the drop list is on your x-axis. The individual bars, individual rows are your individual inputs, in this case revenues, discount rate, marginal tax rate, and so forth. So if you see a green bar on the right hand side means that revenue went up because it's green. So 6623 compared to 5419. So higher revenue implies a higher net present value. So it's positive relationship. For discount rate is a negative relationship because red is on the right hand side and so forth. So very easy to identify positive, negative impacts and which has the highest impact to the lowest impact. That's your tornado analysis. And this is static analytics. It perturbs one input variable at a time. So holding everything else constant. Then later on when we do risk simulation is we're simulating with perturbing multiple things simultaneously. So 5, 10, 1,000 different things can go simultaneously changing, and we're changing different scenarios countless number of times, so thousands and thousands of trials. That would be a dynamic or stochastic analysis. In this case, the applied analytics is static in nature. That's why we call it a static tornado. On here also in applied analytics, we have something called scenario analysis. Under scenario analysis, we have two subtabs. So clearly you go to step 1 before you do a step 2. In step 1, choose the output that you want in this case. So project 1, project 2, whatever. Let's say we choose project 1's net present value. And again, scenario analysis is used to identify different scenarios or sweet spots and hot spots of your model, if you will. So here are all your input parameters that pertains to the drivers of NPV analysis. So I can choose up to 2 because this is a 2-dimensional table. So I can choose, say, revenues or depreciation, whatever inputs that you want to. And you can perturb this plus or minus some preset percentage. You can change the percent, of course, and do a step size. So the default is plus or minus 5%, step size of 0.5%. What that means is it will go through and do a change of a scenario minus 5%, minus 4.5%, minus 4%, all the way to positive 5% with a step of 0.5%. Okay, so if you're happy with what you've set up, you can give it a name. For example, I have saved 2 different scenarios here. You can add as many scenarios as you wish. All you need to do is give it a name, put some notes on here if it's applicable, remind you of what that scenario is all about. So for instance, I saved one here called revenue versus discount rate. I had chosen revenue plus or minus 5% and discount rate from 20% to 38%, step size of 1. So 20, 21, all the way to 38% discount rate. And I've saved it, given it a name. And by the way, it's optional if you want to put color coding on here. So I put a color code to make it red. If the net present value is less than 0, this is what you type in. Yellow if it's between 0 and $50,000 and so forth and so on. If it's greater than $100,000 NPV, I make it green. So you can save these as many scenarios as you wish. Move it up or down, okay, depending on the priority or whichever you want to see first. And when you're done with this, all you need to do is click on Scenario, Output Tables, and out comes your scenarios. So in this example, I only created 2 scenarios, and you see the 2 scenarios here. So choose the scenario that you've chosen, that you've created, and you would see your sweet spots, your hot spots, and so forth. You can create additional decimals as you wish. You can update the calculations if you change some of these settings. You can copy your grid, and again, if you copy your grid, you can go into something like Microsoft Excel and paste that in there. Okay, you can see the values that's being calculated. So in this case, it's 20% all the way to 38%. Okay, and it tells you here your different nodes. The variable, row variable, which means going downwards, is your revenues. Okay, and these and the variable that goes across your column variable is your discounted cash flow, your discount rate. So 20%, 21, 22, all the way to 38%. So if you recall, that's what we did here. Back to the input settings. So we can double click on here again, and you can see that we did a discount rate from 20 to 38%, step size of 1, and the revenue was plus or minus 5% with a step size of 0.5%. That's what we've generated automatically for you. So here are your revenues, and here are your discount rates. So you can create as many scenarios as you wish, thousands of different scenarios, thousands of different cells in here with multiple rows and columns. That's what scenario analysis does for you. So very, very simple without having to run simulations, and you can save, by the way, as many scenarios as you wish with notes, different color coding, and so forth. And all you need to do is when you're done, remember to click save. So whenever you click save, everything will be saved as a single file, regardless of how many scenarios and how many projects you've actually generated, different portfolios and so forth. Everything will be saved as a single ROV project econ file.